So today, we're going to talk about our calorimetry lab. And we're going to focus on our results. And our calculations. Okay. So, results and calculations. So the first thing that we have to do in our lab report for our results section, okay? And don't worry about the introduction, don't worry about the discussion. We'll get to those next week. We handled materials and methods last week. Today we're focusing on results. So in our lab report, we're going to have our results table, right? And so we're gonna go with this format. So item, and then mass, if applicable, in grams. We didn't take the mass of everything. And then temperature in degrees Celsius. Okay? And we didn't take the temperature of everything, so follow along. So today, one lucky group is going to get its calculations done for it on the board, right? So who wants to volunteer? But you got to have good results. Okay, so I saw Kaylee's hand go up first. So Kaylee, you got good results? You have everything?
Yes.
Okay, all right. Shh. So first off, item, empty beaker. Empty beaker, what was your mass of your empty beaker?
30.1.
30.1 grams. Okay, and what was the mass of your beaker with water?
With water, it was 54.9.
Okay, and remember, this is what we're trying to do. So in our lab, we're trying to figure out the specific heat of our bolt. And our bolt is made out of carbon steel. So this is what we have to know up front. The heat absorbed by the water equals the heat released by the bolt. Okay? And so, first things first, we're going to calculate the heat absorbed by the water. So we're going to go Q equals MC delta T. Okay? And so we want to find our mass of water, right? So Q equals mass of water. How do we use these two numbers to get the mass of our water?
You subtract them both.
Good, you subtract them, right? So this is going to be, mass is going to be 54.9 grams minus 30.1 grams. Very good, Angel. Now, specific heat for water we know. Does anybody have that off the top of his or her head? Can somebody tell me what that is?
What?
Specific heat of water.
1.0.
1.0 what? Good, very good, Victor. 1.0 what?
Grams.
1.0, I heard it from somebody, not grams, calories
Over
per grams times what?
degrees Celsius.
Yes, degrees Celsius. Great, Victor. Okay, so look. There you go. So, these two quantities multiplied together, and that somehow looks funky, so I'm going to erase that little
Is
weird.
that a Q or a G?
Q. Q. Over here, that's a Q. Okay? Good.
Oh,
Now, here's the last thing. Delta T. We haven't gotten there yet, right? So, what was the temperature, Kaylee, of the beaker, of the water in your beaker initially? 20 degrees Celsius? Okay. 20 degrees Celsius. That's fine. And then we had the beaker with the bolt. Okay, and that bolt had previously been pretty hot. What was the temperature at that point? 26 degrees Celsius? Okay. 26 degrees Celsius. Okay? So what's the delta? What's the change in temperature here, scholars? On the count of 3, we're all going to look at it. How much did the temperature change? 1, 2, 3.
6 degrees.
Good. So we multiply by delta T. Okay? 6 degrees Celsius times 6 degrees Celsius. Now when you do that, okay,
Did we put that under temp, right?
Yeah, that's your temperature
20 or
change.
26, we put it under temp,
Do I put
right?
6?
So when we calculate heat absorbed, we multiply by the change in temperature. So our initial temperature for water was 20.
And then
It changed by 6 degrees. So that's what we multiply in.
Okay.
Okay? All right, so let's go ahead and do this calculator math here. So you get Q equals 54.9 minus 30.1, so that should be 24.8 grams times 1.0 cal per gram degrees Celsius times 6 degrees Celsius. What happens to the gram? What happens to the grams here, scholars? Yep, they go away. What happens to the degrees Celsius?
They cancel out.
Cancel out. What's our final unit going to be?
Calories.
Calories. Okay? So you multiply that out, 24.8 times 6. That's going to be about 150, but you're going to have to subtract, excuse me, 1.2, so that should be 148.8. Let's double check. So 24.8 times 6. Yeah, 148.8. So 149, we'll round it, calories. Okay, that's much heat was absorbed by how much heat was absorbed by the water. That's also how much heat was released by the bolt. And one little last thing we need to know about the bolt. Okay, the bolt. So we have a bolt. Okay, this is our hot bolt. Okay, how much mass did that one have? What do we write down?
18.7.
18.7 grams. Good. That was true for all of us. And what was the temperature of that bolt when it was hot? When it was boiling in the water bath? What was the temperature, Kaylee? Did you have that written down? Lily?
Wasn't it 100?
Yeah. The water was boiling, so it was 100 degrees Celsius. Okay? 100 degrees Celsius. That was the temperature of that water. We are at sea level. That water was boiling. It was 100 degrees Celsius. End of story. So here's what we can do. We can calculate the specific heat of the bolt. So remember, we can rearrange this equation and solve for C. So now we're going to look for C. Okay? And when we do that, we find that C equals Q divided by M delta T. That's right, Terrell. Very good. Now we just plug in, right? So our Q was what?
149.
Okay.
Well, I thought that was our C cal. Oh, never mind.
Okay, that's our Q, right? Okay, 149 calories. What's our M in this situation?
Oh, our M.
What's our M?
Mass.
For what though? What are we trying to solve the specific heat of?
It's 24.8.
The bolt. What was the mass of the bolt? Where? 18.7 grams, right? So 18.7 grams times, okay, the change in temperature. What's our change in temperature?
6.
That was the change in temperature of what? Was that the bolt?
Yeah, that was for the.
That was the water.
For the water.
Water. How much did the bolt change in temperature?
26 minus 100.
Okay, 100 minus 26, very good, Terrell. That gives us 74 degrees Celsius, okay? Right? So look, this number here, this comes from 100 degrees Celsius minus 26 degrees Celsius, okay? That's what that is. That's our delta T, right? Our change in temperature for the thing we're interested in, which is the bolt, right? That's the change in temperature of the bolt. Now when we do all of that, that's going to be about 2 over 19, so let's call that 2 over 18 or 1/9. It's going to be about 0.11. So that divided by 18.7 times 74, yeah, you get 0.11. So you get 0.11 cal per gram degrees Celsius, okay? Now the last calculation that we have to do, so this is our C for our bolt, okay? We did a good job. You guys did a good job. Our percent error calculation goes like this. So percent error, okay, percent error, what we do is absolute value of known minus experimental, all divided by our known value, and you multiply that by 100, okay? So in this case, the specific heat for carbon steel, yeah, you should write all this down. Okay, this is our known value. That's going to equal 0.12 cal per gram degrees Celsius, okay? We plug that in and we say 0.12 minus 0.11, all divided by 0.12. Take our absolute value, multiply by 100, and that's going to give us roughly, I'd say about 8%, 8.5%, so 0.1.
And we all have that same information?
Yeah, well, give me a second. Divided by 0.12, not quite. So yeah, you get 8%, so 8.3%, so you get 8.3% error, okay? So that is good for Kaylee and Leslie's data, all right? You're gonna have to use your data. So look, you plug in your values here, and then you do the same calculations, but with your values, okay? So your delta T's might be a little different. Your masses might be a little different. Your bolt mass isn't going to change, but your other masses might change. And is that okay? Can we handle this? Yeah, we see how to do this now, okay? All of it's up there for us. Leslie, quickly.
Where did you get the 18.7?
The 18.7 is the mass that I measured for all of the bolts. It turns out that all the bolts were 18.7 grams, give or take 0.1 gram, but the average was 18.7. We're going to stick with that for all of us, okay? Because otherwise you got to take the bolt out of the water, dry it off, weigh it again. It's a mess. All right, so we're just going with that blanket mass. Any other questions?
8.3%, correct.
8.3%. That's Leslie's answer. Okay, so Leslie and Kaylee will go with that answer. Other questions? Or was it just Kaylee's data? Leslie, that wasn't your.
It was.
Oh, you guys. Okay, so sorry, Leslie. So that's Kaylee and who else? Sandra and Angel and Leilani. Okay, so you guys all got hooked up. All right. Any other questions? Okay, I'm going to come around. What I want you to do right now is work on your calculations. You should be able to do all of these. If you get stuck, what do? Send up a flare. Good. Okay, let me know, and Miss Sandoval and I will come around and help. All right. Good luck, scholars.